What is voyage planning? Who is responsible? How do we comply with the rules? And how do we utilize the features and functions available in an ECDIS? The purpose of voyage planning is to support the bridge team and ensure that the ship can be navigated safely between ports from berth to berth. Our voyage plan should cover ocean, coastal, and pilotage waters, and according to STCW regulations, be planned in advance. A voyage plan should aim to establish the most favourable route, while maintaining appropriate margins of safety and safe passing distances offshore. The following factors are amongst those that should be taken into account. The marine environment, the adequacy and reliability of charted hydrographic data along the route, the availability and reliability of navigation aids, coastal marks, lights and radar conspicuous targets for position fixing along the route. The type of cargo can influence route selection. Any routing constraints imposed by the ship, for example, draft, type of cargo, etc. If possible, avoid areas of dense traffic. Take into account weather forecasts, current, tide, wind, swell and visibility conditions. If possible, avoid areas with onshore set or areas where onshore set can be expected. Whenever possible, follow traffic separation schemes and follow ship reporting procedures. Check technical systems before departure and, if possible, take into account previous experience of their reliability. Take into account your own experience with the planned route and type of ship. There are 4 main stages in the planning of a safe voyage. Appraisal, i.e., the collection of information and validation of all relevant information. Planning, i.e., the presentation of the raw data into information and the strategy to be used. The execution of tracking, voyage and communication control. Monitoring, i.e., ensuring that the voyage plan is being followed. Voyage planning can be done the traditional way by using up-to-date paper charts and other relevant nautical information. If an electronic chart display information system with approved and up-to-date electronic navigational charts is available, such a system offers many possibilities for professional and efficient voyage planning. In the following pages, a description of functions which may be found on an ECDIS system is described. A base display represents the minimum amount of information permitted in a chart on the screen. A typical base display shows the following information: coastline, indication of subsea dangers, traffic systems, After startup of the ECDIS system, normally a so-called standard display is presented on the screen. A standard display normally includes the following information: coastline, indication of subsea dangers, traffic systems, chart boundary, aids to navigation, caution areas, caution notes. The navigator decides which elements are to be included in the standard display, other than the base display information, which is always included. All other information in the chart database may be displayed on operator request when needed. Examples of such information are pass track labels, spot soundings, depth curves, cables, land details, place names, object names, for example, buoy names and numbers, seabed text, light ranges, scale bar labels, latitude-longitude scale. The zoom function allows the navigator, in different ways, to select the appropriate chart scale for the actual situation. The pan function allows the navigator to move the current chart on the screen in such a way that the appropriate chart segment is shown on the screen. Most ECDIS systems can operate in two modes: route monitoring, route planning. An ECDIS system, when powered up, will normally automatically start in route monitoring mode and display its own ship's position on the chart. The following definitions of a route plan can be used in connection with ECDIS. A route plan is a description of how a voyage is to be carried out. The simplest version of a route plan consists of waypoints drawn in the chart. Straight lines, which show the intended sailing between points, connect the waypoints to each other. A waypoint is a position where the ship's course is to be changed. Waypoints can normally be inserted by pointing to the required position in the chart or typing in the actual latitude and longitude from the keyboard. The line connecting two waypoints is referred to as a leg. In an ECDIS, every stored route and waypoint gets its own unique identifier. A ship's course change can be described in detail by specifying the turn radius. The actual circle segment will be drawn on the chart. The off-track limit specifies a distance on both sides of the course line. The off-track limit is used to control the ship's deviation from the planned track. The decision where, on a given course line, the next waypoint should be located can, under certain circumstances, be decided by a certain distance to a known mark, 2 marks observed through a straight line. The turn point functions allow the navigator to use these criteria to determine these points geometrically in the chart picture. The following information may be inserted in the route plan: the route name, the start time for route, waypoints, for each waypoint, the following information may be inserted: the waypoint name, the position, longitude and latitude, the wait time at waypoint, the turn radius, the message, the turn point, the off-track limit, the cruise speed, the max speed. Based on these data, the ECDIS system can automatically calculate the number of waypoints on the route, the estimated time of arrival, the course of each leg, the length of each leg. Waypoints and corresponding data can be changed or removed. Waypoints can easily be moved on the chart. When a waypoint is moved, the part of the route that is affected is changed correspondingly. This means that it is easy to see the consequences of moving a waypoint. All routes in an area are drawn on the chart screen. In addition, an overview of all pre-programmed routes in this area is displayed in a list. The navigator can select a suitable route for the voyage from this list. Specifying the waypoints can create new route plans. In addition, new route plans can be created based on existing plans. Create a new route by making a copy of an existing route and then modifying it. Existing route. When a route planning process is completed, it is not only recommended, but also good seamanship, to require that the route be validated. This implies that the system checks that the route with off-track limits does not cross the safety contour. Some ECDIS systems on today's market can import and export electronic charts and routes to and from integrated navigation systems. Press the red square to install charts. The safety contour is the most important safety feature found in an ECDIS system. A safety contour is a line in the chart that defines waters with safe depth in relation to the actual ship. The ECDIS system continuously checks if the ship, within a specified time, may cross the safety contour, and if so, gives an alarm. The navigator can choose the depth contour as the safety contour, or he can specify his own safety contour. Press the red squares to change the safety contour. When powering up an ECDIS, the system automatically starts in route monitoring mode and displays own ship's position on the chart. In this example, the chart is displayed in night colours with north up. This is the standard ship symbol used on ECDIS systems. The direction of the course and speed vector connected to own ship symbol is the course and speed made good. The length of the vector is proportional to the speed of the ship. Each line segment represents 1 minute. When the ship is shown in true scale on the chart, the concentric circles are substituted by the contour of the ship. Own ship is by default located in the center of the display. The operator can change this position. Additional information may be presented in a separate window or windows. The navigator can turn this window on and off. The following information may be displayed in the window: the date and time, the chart scale and original scale, the elements included in standard display, the current route with data for active waypoint, the range and bearing with positions, the chart, units of measurement, depths and heights, ENC date and datum last update of the original chart, various mode data, messages. As default, the chart on the screen is oriented north up, and the ship moves in the chart the same way as on a north stabilized true motion radar display. A scale bar is always shown on the chart. The navigator may find course and distance from the ship to any point in the chart, or between any 2 points in the chart. In addition to course and distance, the positions for the points are presented. The navigator may display all available routes on the screen and select a suitable route for the voyage. All data about the waypoints are presented in a waypoint list. During sailing, the navigator may introduce changes to the active route. This is done by moving a waypoint to the ship's position, or creating a new waypoint in the ship's position. The electronic chart is object-oriented. This means that when the navigator selects an object in the chart, all available information in the chart database about the selected object is displayed. The navigator note function can be looked upon as the navigator's second memory. The navigator can point at a navigator's note symbol in the chart and get the information connected to that symbol displayed on the screen. The navigator may introduce new notes in the chart by pointing on the required position for the new note and typing the actual note text. The ECDIS system is required to receive input from the best position sensors available at any one time. However, when the automatic position sensors fail to provide input to the ECDIS, manual specification of data is possible. Whenever manual input is used, information given by the ECDIS must be used with great care. Parameters can be changed in monitoring mode. The grounding alarm time, the ship vector length, the ship bearing line length, the pass track to be displayed, the pass track time label interval. When an off-track limit is defined for the current route, an alarm will be given to the navigator whenever the ship's position is outside this limit. If own ship's position, course and speed is calculated to lead to a grounding, an alarm will be given at the time specified. For example, 6 minutes prior to the expected grounding. On most ECDIS systems, tracked targets provided by an ARPA system can be displayed on the ECDIS screen. Targets from ARPA are shown on the ECDIS display with their own symbol. Normally there is a limit to how many ARPA-derived targets can be displayed on the ECDIS. There are ECDIS systems on the market today that can handle 50 ARPA targets.